started with the layout examples using the CPW architectures. Basically, what we're going to look at and kind of drill into is the DLR and REP, redundant Ethernet protocols. This is kind of how it should be laid out. This is tried and true. Rockwell, Cisco, Panduit have gotten together and said, hey, this is how you need to do it. This is how things need to be laid out. This is how it works. It's tested. It's tried and true. So DLR use cases. So device level ring is where we can have a mixture of either all endpoint devices or switches and endpoint devices in a ring to have redundancy, so that if there's a break in a network cable or a cable gets unplugged or whatever the case may be, a faulty port, it has a way to go back around to actually have connectivity. The same way with rep, but we'll get into that shortly. Any DLR compliant device can be configured as a ring node. So there's only certain devices that we can use that with. One of the biggest things to point out is the convergence time of DLR is 3 milliseconds or less. I don't know if you guys have heard of or know about spanning tree protocol, but that could be 30 seconds convergence time. So you're cutting that down significantly with DLR. Spanning tree protocol, you could have everything connected up in a ring, but if there's a disconnect, you're looking at up to 30 seconds before it converges and figures out, hey, here's how I get back around and pick back up where I left off. So that just doesn't cut it in a production environment. It may cut it in an IT environment, but not in an OT environment. These are the different DLR examples. So we could have all switches, mixed switches and endpoint devices, or all endpoint devices. So here's a typical active backup supervisor configuration where we'd have two Stratix switches, one being the active supervisor, the other being the backup, so that if something fails in this area, it knows how to get back around to this backup supervisor and also back around to the active supervisor. So I'm going to give you an example, an IAB, of how we could actually set up in an integrated architecture builder. I've already got one set up here. Here's kind of a mixed scenario where you could have a switch, control logics, a Kinetics drive, a Flex IO there, a drive, all in a DLR ring. So if anything gets cut here, 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 any of those areas, it has a way to converge back around and get reconnected. Now the only instance where it would become a problem is if you had two losses between, let's say, the Kinetics and the Flex IO, and then another one here between the switch and the Flex IO, then the Flex IO is going to be an island of its own. You can't get to it. So now moving on to the resilient Ethernet protocol. This is just for switches only. So it's a similar technology, but it's Cisco only. And since Stratix switches are Cisco switches, so this is a switch level topology, resilient Ethernet protocol only. As you can see, we were talking about STP. It acts independent of STP, but it does notify about potential topology changes. So if you do have spanning tree running out on the edge of one of those switches on other ports, it can let those know, so it knows how to direct that traffic. That's one of the good things about having a rep switch ring over a DLR ring. The only caveat there is the convergence time is a little bit higher. On rep, it's between 20 milliseconds and 50. So that is a little bit of a difference. You can have both technologies running as long as the switches support it. So you could have a rep ring such as this one, but you could also have off of this switch, any of these switches here, you could have actually a DLR ring as well. So you could have those devices isolated. So again, on the IAB, we can give some examples, and you can also, it's really easy to use. You can also go down into there and select an access switch. So you've got all your 5200, 5400, 5410, just a myriad of Stratix switches. So I could actually drag and drop a switch in here and just add it in really easily. So I could just go in, click there, add this, draw it out. Ask me what I want to use, copper, whatever kind of cable I want to use, or fiber, yep. So I could do that. It's going to give me an error here because I've got a loop within a loop, but I can actually cut that right there, and there I've expanded my ring at that point. So again, rep is for switches only. DLR can be endpoint devices or a mixture of supported switches and endpoint devices. So here's a little bit of recommended use cases. Use cases of flex links, ether channel. It's kind of like ether channel is bonding, and flex links is a form of bonding as well, where you have two connections to the same switch or the same device. But this kind of tells you what's supported, when to use it, and where to use it. So you can see here the Stratix switches. It tells you where to use your rep single, as well as the catalyst and the Stratix 5400. So it's kind of a good little matrix there. Network address translation. Well, there's going to be examples and times where you're going to have multiple skids coming in that have the same IP range, and they're going to say, hey, we want to go ahead and network these together. So you're going to have one of two options. You're either going to have to change the IP addresses on one of those skids or multiple skids, or you're going to have to use network address translation in order to converge those and have connectivity between all of them without having any sort of issues with overlapping IP addresses. For a good example here, if you've got a machine, one with IP range of 192.168.1.1 through 254, you've got a PLC at 1.2 and an HMI with an address of 1.3. Here's another one. What happens if I actually connect those two? You're going to get IP conflicts. You're going to cause major issues at that point. So a way to overcome that, we're going to introduce a Stratix 5700 switch with NAT. We're going to change its public IP. We're going to translate that IP. We're going to change the IP on the other side, public IP. So we're going to have one translated to 10.10.1.100. The other side is 10.10.2.100. So I can still have communications between those two lines, but I don't have the IP address conflicts. So we can also use a device called a NAT-R without utilizing an actual switch. And a NAT-R is an actual layer 3 device, routing device, to do that network address translation. So same example, you're going to have your original IP, it's going to translate it over to here. Original IP from there is going to translate back over here, so you can have communications between those two devices that are technically on the same IP range or on the same network. So this gives you a really good overview of your public, private, how you would do your translations. So to add a translation table, this is just kind of an example to add a translation table for a NAT device. And it just goes through to tell you, hey, here's your translation rule. I'm translating the public IP or the private to the public, and add the rule. That's pretty much it. So it's pretty straightforward. There are some limitations. The NAT-R is limited to 32 translations and allows 5 advanced ports. And I'm actually on a Stratix 5800 switch. So we'll kind of go through the differences with the new switches, but I wanted to show this one because it's so much better of an interface. I know you guys have probably been more used to the 5700s. That's really slow when you're trying to log into them and you're sitting there watching grass grow while it loads up. So basically you would add a new configuration, which I already have. So I'm just going to click on that and we'll kind of show how you would add a single inside to outside IP address. So or public to private. So let's say we wanted to, I've already added a 192.168.1.252. I want to translate that to a 10.1.1. Let's say we're going from having to push some sort of data up to, a different thing out in, maybe even on the enterprise side, who knows at this point, maybe pushing some data up somewhere. But all you basically do is 192.168.1.253. Let's just make it simple. And at that point, we just click on add. So we've added those two translations that easy, and we update and apply to device. And the only other thing we have to do at that point, or at this point, is we have to associate an interface. So you are limited in which interfaces you can use those with. On the 5700s, it's the 2 gig ports. Yep, 2 gig ports. And on the 5800s, it's port 1 and port 2. And you could technically have 2 separate NATs on the same switch. So I could have 2 separate ones on this switch where I could have maybe going to a 10.x and then going out to a 172.x on gig 1.2. So we could have that sort of scenario as well. So we already got it. Matter of fact, let's just dive into the rep. We've got actually a demo here set up with a 5800 and 2 5700 switches, and we do have rep configured. So we're going to actually look at the rep monitoring right now, and it basically shows us we've got the switch names. So we've got the 5800. It's kind of monitoring the traffic. So gig 1 and or 1/8 and 1/7 are your primary and secondary edge ports, and then in between there we have the 5700 there and the 5700 there. So everything is all great, wonderful, happy. So basically we have a ring in between these switches. If I pull that, which breaks the ring, it's going to give us a little bit of a warning here. Once we refresh this, we should still have full connectivity, and I should still be able to ping every device, but it's going to tell me, hey, there's an issue with the ring. So as you can see, we have full connectivity, but we got a fail on the 5700 or the ES&E test 5700, but I can still ping everything. So if I do ping 192.168.1.12, it should ping here in a second. So there we go, 13. So everything is pinging, everything is happy, but if you'll notice, we've got red blinking lights all over the place here. And that's to indicate, hey, there's an issue there somewhere. If a rep wasn't set up and we had these just daisy chained, there would be no red lights. There would be no lights going on at all for warnings of, hey, there's an issue. So once we plug that back in, we'll look at the config again and we'll say everything is happy. It's probably going to have a different alternate port, but those should go back to green here momentarily, and there we go. So now everything is fine. Now if I unplug the second switch, then we would have issues because we have more than one failure between the switches. So you are limited to that. But if we refresh this now, we should see everything is all happy now. So. Managed versus unmanaged switches. I mean, we're just going to give a high level of, what the differences are. Obviously, on the fully managed or a managed switch, even a 2500 switch, you have to configure it. It has VLAN support. You have loop prevention, rep, port security, visibility, diagnostics. With an unmanaged switch, you have none of that. Now, there are instances where unmanaged switches are fine, but for the most part, we try to get everybody to use managed switches when and where they can, because it gives you more visibility into your network, more troubleshooting possibilities when there is an issue. So there are instances where you maybe have IO devices or something just hanging off that you don't care about. But most of the time we want everybody to use fully managed switches, even if it's a lightly managed Stratix 2500, which is not much more than a 2000. So The 5800s, which we were just looking at, they give you a lot of options as far as expandability and what you can do with those. So there's 16-port expansion capabilities on those switches as well. Fixed or modular, most of the time we're going to recommend go with a modular because they're always expandable. If you get a fixed switch, you can't expand it later. So pretty much standard across the board, the flash cards across all the Stratix switches. The 5200s are replacing the 5700s. The 5700s are active mature, so these are the direct replacement for those. It has the same user interface as the 5800s, which is much better than the 5700s. So now I'll kind of show you some of the features of that. So it does have like we said, the better interface. We do have the option of DLR, which is coming out soon for those. Layer 2 firmware only on the 5700s, where the 5300s you can get layer 2 or layer 3. So you can have the capability of doing layer 3 routing on the 5800 where you're not going to be able to on the 5200. Also on the 5200s you can have just the standard like you have on the 5700 2 gig uplinks, or you can have an all gig option, which is great because you don't have that now on the 5700s. The faceplates and the AOPs are planned for release. So we'll just kind of give you an overview of a little bit of the features. One of the biggest things is that obviously you can see the OS, the interface is much snappier. One of the big things on this one is you actually have direct interfaces direct interface to the command line. So if I wanted to look at the configuration, which most of you guys aren't, but it does come in handy if you're doing a lot of commands to make changes on switches. But if I just wanted to do a show run command, there's the entire configuration of the switch right there. So I could copy that, export it, whatever I wanted to do. So it breaks down and tells me pretty much everything about every single port. There's your NAT instance. So where we set it up inside the graphical, that's basically what it put in the configuration. So I come from an IT background where we only use command line interface. We didn't use a graphical user interface to configure switches. So for me, this is great because it makes all the difference in the world, because I can do things much faster in the command line than I ever could, muddling my way through the 5700's user interface, just clicking and waiting. So it's kind of nice to have that. Troubleshooting, you also do have a lot better troubleshooting capabilities here. Ping and trace route, so you can actually ping from or to a destination. So if I wanted to ping one of the other switches, I could ping it, actually have it run here and show me, hey, there we go. I've got a success rate. If I wanted to trace route, I could do the same thing. It shows me how many hops I have from this device to the other device. Also, something we use lots of times, and I wanted to point this out because I don't know if you guys are used to plugging something into a 5700 or one of your switches and it stays yellow for 20, 30 seconds before you get a green light and you're able to connect, right? There is something called smart ports where you can actually set those up to where once you plug a device in, it doesn't have to figure out what's plugged into that device. It automatically, you have connectivity pretty much instantaneously. Where if you leave those ports unconfigured and just out of the box the way they are, it's got to figure out, hey, what am I talking to? Did you plug me into another switch? Did you plug me into a device that has multiple Macs coming through it? What did you plug me into? So as a rule of thumb, what I usually do is set up all of those access ports as multi-port automation device ports. What that allows that to do is if I've got multiple MAC addresses or multiple devices coming through that one port, it's not going to limit that. Where if I change that port's role, for example, if I change this port's role to an automation device, it's going to block every other MAC address except for the first one it sees. If I set it for desktop for automation, that's saying I'm going to plug my laptop into it. And you could do that, that's fine. If I set it switch for automation, that means, hey, I'm connecting from switch to switch, and I want to allow all VLANs. But I usually set the access ports to multi-port automation devices, because that way I know whatever I plug into, whether it's a single device or many devices that are maybe in a linear topology, it's going to allow all those devices through there. It's not going to block anything. So, and it allows you to plug in and get instant connectivity without waiting for that connectivity. So the menu structure, debug, ping and trace route, direct interface to CLI, we kind of went through that. Factory talk view, faceplates. Here we have the current portfolio overview. So we have all the way from the unmanaged Stratix 2000, and we talked a little bit about the 2500s, 5700s, 5200s, 54, 58, and the 5410. You guys are probably going to kind of land in this area or this area, so I don't think you're going to deal much with the 5410s. This gives an overview of, hey, you know, what's your customer challenges? You know, you have loop protection or prevention on the lightly managed, on the fully managed, and on the high performance. You have virtual segmentation, VLANing across there. You have collaboration and all that fun stuff with visibility and tools on across the board. Port security and segmentation, you have that across the board. So you don't have as much resiliency or redundancy on, or any on the lightly managed. That's kind of why we don't really focus on that. But I'd rather see a lightly managed switch used than a Stratix 2000, to be honest with you. So, and this kind of gives you, this is a good slide because it gives you, you know, kind of an overview of you know, what all you have, the total max ports, fiber ports, copper ports, gig, 100 megs, so on, and the fiber support, and so on and so forth. So that's a really good slide there to kind of help you decide what you need from there. And that's the expansion module options for the 5800s, which is quite wide actually. Layer 2 firmware at this point. Layer 3 firmware on the 5800s. There is something called advanced features. I wanted to point this out on the 5800 because I get asked this question, and I think you do as well, Eric. What are the advanced features? What does it entail? Eventually, this will entail DLR, but parallel to redundancy protocol, trust sec, high availability, HSR. So they're gonna, whenever they have new firmwares, they're gonna, you know, probably add some more things to that. So we already discussed this, but now that this switch is active, mature, the 5700, the 5200 is going to replace it. Of course, the 6000, 8000 are defunct. I don't know if anybody's aware that Network Manager even used it. It's discontinued. So.